Experimental designs and surveys are useful and powerful in finding answers to research questions through data collection. The process of selecting the right individuals, objects, or events as representative for the entire population is known as sampling, which we will discuss further in this lecture. The learning objectives for this topic are as follows. In learning how representative data can be collected, a few terms, as listed below, have first to be understood.
Target population is a group about whom the researcher wants to know more and from whom a sample will be drawn. For example, in your research, you need to know a group of individuals or samples that you want to study more, or what information that you want to know more about them. So this is our target population of the study. Second, it is about sampling frame, where it is the source from which elements or sampling units, for example respondents, are chosen. An example of sampling frame are city map, telephone books, electoral rolls, customer list, and etc. So it is a list of names or a list of samples of the overall target population. So from here we can select samples that we want to be involved in our study. In sample selection, you might be wondering how to select the respondents and how many of them do we need to be able to generalize our population. So in next slide, I will show you on the types of sampling techniques that we have, and I will also show you on how can we calculate the sample size in our study.
There are two major types of sampling design, probability and non-probability sampling. In probability sampling, the elements in the population have some non-zero chance or probability of being selected as sample subjects. In non-probability sampling, the elements do not have a known or predetermined chance of being selected as subjects. Probability sampling designs are used when the representativeness of the sample is of importance in the interest of wider generalizability. When time or other factors rather than generalizability become critical, non-probability sampling is generally used. Each of these two major designs has different sampling strategies. The choice of sampling procedure is a very important one. The unrestricted probability sampling design, more commonly known as simple random sampling, every element in the population has a known and equal chance of being selected as a subject. Simple random sampling has the least bias and offers the most generalizability. However, this sampling process could be cumbersome and expensive. In addition, an entirely updated list of the population may not always be available. As an alternative to the simple random sampling design, the restricted probability design can be used. These probability sampling procedures offer a viable and sometimes more efficient alternative to the unrestricted design we just discussed. Efficiency is improved in that more information can be obtained for a given sample size using some of the complex probability sampling procedure than the simple random sampling design. The systematic sampling design involves drawing every nth element in the population, starting with a randomly chosen element between 1 and n. Stratified random sampling involves a process of stratification or segregation, followed by a random selection of subjects from each stratum. The population is first divided into mutually exclusive groups that are relevant, appropriate, and meaningful in the context of the study. Once the population has been stratified in some meaningful way, a sample of members from each stratum can be drawn using either a simple random sampling or a systematic sampling procedure. The subjects drawn from each stratum can be either proportionate or disproportionate to the numbers of elements in the stratums. The proportionate stratified random sampling design provided that members represented in the sample from each stratum will be proportionate to the total number of elements in the respective strata. These proportionate sampling decisions are made either when some stratum or strata are too small or too large, or when there is more variability suspected within a particular stratum. Stratified random sampling involves stratifying the elements along meaningful levels and taking proportionate or disproportionate samples from the strata. This sampling design is more efficient than the simple random design because for the same sample size, each important segment of the population is better represented, and more valuable and differentiated information is obtained with respect to each group. In cluster sampling, the target population is first divided into clusters. Then a random sample of clusters is drawn, and for each selected cluster, either all the elements or a sample of elements are included in the sample. Cluster samples offer more heterogeneity within groups and more homogeneity among groups, the reverse of what we find in stratified random sampling, where there is homogeneity within each group and heterogeneity across groups. A specific type of cluster sampling is area sampling. Area sampling is less expensive than most other probability sampling designs, and it is not dependent on a sampling frame. A city map showing the blocks of the city is adequate information to allow a researcher to take a sample of the blocks and obtain data from the residents therein. The key motivation for cluster sampling is cost reduction. However, cluster sampling exposes itself to greater bias and is the least generalizable of all the probability sampling design. There are two types of cluster sampling, namely single-stage cluster sampling or two-stage or multi-stage cluster sampling. In non-probability design, the elements in the population do not have any probabilities attached to their being chosen as sample subjects. This means that the findings from the study of the sample cannot be confidently generalized to the population. Some of the non-probability sampling plans are more dependable than others and could offer some important leads to potentially useful information with regard to the population. The convenient sampling refers to the collection of information from members of the population who are conveniently available to provide it, and the choice of respondent is up to the interviewers. The purposive sampling confined to specific types of people who can provide the desired information, either because they are the only ones who have it or they conform to some criteria set by the researcher. The types of purposive sampling is the judgmental sampling and quota sampling. The judgmental sampling design is used when a limited number or category of people have the information that is sought. In such cases, any type of probability sampling across a cross-section of the entire population is purposeless and not useful. Quota sampling, a second type of purposive sampling, ensures that certain groups are adequately represented in the study through the assignment of a quota. Generally, the quota fixed for each subgroup is based on the total numbers of each group in the population. However, since this is a non-probability sampling plan, the results are not generalizable to the population. Snowball sampling is where research participants recruit other participants for a test or study. It is used where potential participants are hard to find, such as the sensitive respondent, for example, a sample of abused working women professionals. In determining how many units should be selected as sample, we should look into the following criteria for non-random sampling and random sampling. Determination of sample size is governed by the extent of precision and confidence desired. The confidence reflects the level of certainty with which we can state that our estimates of the population parameters based on our sample statistics will hold true. A 95% confidence is the conventionally accepted level for most business research, for example, survey, and for the experimentation, normally 95 and 99% confidence level. The other aspect while making decision on the sample size needed to do research is the variation. To what extent is the variability in the population on the characteristic investigated? Whenever we use a representative sample to guess something about a full population, our guess will contain some uncertainty. Any level of error can be accountable for the choice as long as the errors are small. This is the formula used if we know the population proportion. If we know the variance of the population, then we will use this formula.